Good morning, class. Welcome to another learning session in General Mathematics. This is a continuation to our previous discussion on the operations on functions. Now, our main focus for this presentation is on the composition of functions. Alright, so let's have the formal definition. Let f and g be functions. So the composite function, denoted by this one, is defined by this one. So the composition of f and g is simply equal to f of g of x. So meaning, we have to evaluate the function f at g of x. So we will only be doing evaluation of function. So the process of obtaining a composite function is called function composition. Alright, so let's illustrate the concept. Write the following functions. So we have the following functions f of x down to the capital F of x right here. So for example, the first example, find and simplify the composition of g and f. So let's answer this one all together. The composition of g and f, denoted by this one. By definition, that's just simply equal to g of f of x. Alright, so we know f of x. F of x is actually equal to 2x plus 1, so we will just simply replace f of x by its value, which is 2x plus 1. Now, since we will be solving g of 2x plus 1, so meaning we need to determine what is our function g of x. And based on the given, that's simply equal to the square root of x plus 1. Now, since we will be solving g of 2x plus 1, so we will only replace x right here with 2x plus 1. So, meaning this is just simply equal to the square root of replacing x with 2x plus 1. We have 2x plus 1, then we still have 1 right here. So, and then combine like terms, we come up with our result 2x plus 2. So this is how are we going to solve the composition of g and f. So I hope it's clear. For the next example, we have find and simplify the following composition. So we have the composition of q and f, denoted by this one. That's simply equal to q of f of x. Now, based from the definition, now what is f of x? The f of x is 2x plus 1. So the same process with what we did a while ago. We will replace f of x by its value, which is 2x plus 1. Now, since we will be solving q of 2x plus 1, then we have to find out what's the function q. Based from the given, that's simply equal to x squared minus 2x plus 2. So we have x squared minus 2x plus 2. Now, since we will be solving q of 2x plus 1, so we will only replace all x right here with 2x plus 1. So just simply following this pattern, we have something like square, we have minus 2 and then plus 2, and again we will be replacing x with 2x plus 1. So we have 2x plus 1, we also have 2x plus 1. Now recall that when you in your junior high school, the square of a binomial of the form a plus b squared, the result is actually a trinomial whose first term is simply the square of a squared. The middle term is simply the product of the terms ab, so that a times b is ab, multiply it with 2. So we have 2ab plus the last term is simply the square of b squared. Now we will be using this pattern to solve the square of 2x plus 1. So following this pattern right here, the square of 2x plus 1 is simply, we have the square of 2x times the product of the terms 2x and 1, multiply it with 2. So 2 times 2x times 1, and then the square of 1 the square of 1. Alright. Now, we will be distributing negative 2 to all of the terms. So, meaning we will be multiplying negative 2 to 2x and then negative 2 to 1. So, doing so, we have negative 2 times 2x, that's negative 4x, and then negative 2 times 1, that's negative 2, and we still have plus 2 right here. Then we can just perform algebraically. So this is the square of 2x is 4x squared. 2 times 2x times 1 is simply 4x. 1 squared is simply 1 minus 4x. Now negative 2 plus 2, that's actually 0. 4x minus 4x is also 0. So we are left with 4x squared plus 1 as our value for the composition Q and F. Alright. Now what about the other one? No? So the composition of F and Q. So is it the same with composition of Q and F? So we will find out later. So by definition, this is just simply equal to F of Q of X. So we will replace now the innermost function, which is Q of X, with its value. Its value is actually x squared minus 2x plus 2. So we will replace that. We have x squared minus 2x plus 2. Since we will be solving this one, then we need to find out what is the value of our f of x. So based on the given, our f of x is actually equal to 2x plus 1, if you remember. So 2x plus 1. So since we will be solving this value, we will replace all x with this one, x squared minus 2x plus 2. So we have something like, we have 2 times and then plus 1, following this pattern. So we will replace x with this trinomial. So x squared, I'm sorry, we have x, can just delete this one for the meantime, minus 2x plus 2. So we can actually distribute 2 to all of the terms inside. So 2 times x squared, 2 times negative 2x, and 2 times 2. Alright, so doing so, 2 times x squared is simply 2x squared. 2 times negative 2x is negative 4x. 2 times 2 is 4, and then plus 1. Then just simply combine like terms. We come up with 2x squared minus 4x. 4 plus 1 is actually 5. So this is now our value for the composition of F and Q. Now, finally, how do we compare based on the result? How do we compare the composition of Q and F and the composition of F and Q? Are they the same? So based on the result, they are not the same, or meaning they are not equal. So I hope it's clear. So we can actually proceed now with the last example. So find and simplify this one. So let's solve this one together. So we are tasked to solve the composition of F and R, but the value of our x this time is 5. So by definition, this is F of R of 5. Now we need to solve first this one, R of 5 now. So we have to find out first what is R of x based from the given function. So R of x based on the given is 2x plus 1 over x minus 1. So 2x plus 1, we have 2x plus 1 over x minus 1. Since we will be solving R of 5, so we have R of 5, since we have R of 5, therefore we will only replace all x with 5. So we have 2 times 5 plus 1, 5 minus 1. Now What is 2 times 5 plus 1? That's 11. And 5 minus 1 is 4. So that's actually that's actually R of 5. Now we will actually replace R of 5 with its value, which is 1/4. So meaning we can actually rewrite this something as f of R of 5 base 8. R of 5 is simply 11/4, so we will replace. Now remember, since we will be solving this one, then we need to know what is our f of x. So based on the given, f of x is simply the greatest integer function of x plus 1. So the greatest integer function of x plus 1. Right? So meaning we will replace, since we will be solving this one, we will only replace x with 11/4. So the greatest integer function of 11/4 plus 1. 11/4 is just simply equal to 2.75. And by the definition of the greatest integer function, that's basically the maximum of all integers less than or equal to this one. So what are the integers less than or equal to this one? So we can have 2, we can have 1, we can have 0, and many more. So the maximum of all those values is actually 2, and we still have 1 right here. So 2 plus 1 is equal to 3. So this is now our result for the composition of f and r, but this time our x is actually 5. Right, so I hope it's clear, class.